land. For one reason or another, everyone has an interest in land, usually in particular parcels of it. We ranch it and farm it, build houses or commercial buildings on it, and for these reasons, among others, we have our particular parcel marked on the ground by a land surveyor. When it comes time to sell our land or purchase a new parcel, we have the land assessed. Of primary importance to this assessment are the survey markers defining the location and extent of the parcel. Over the course of time, these survey markers become more and more difficult to locate, and some are obliterated entirely. Let's look at the tools and techniques used by the surveyors and technicians of the Surveys and Lands branch in searching for these sometimes elusive lot corners, and in some of the ways these corners have been marked over the years. Our first step on receiving the assignment to go out and locate the boundaries of Lot 123 Utopia District is research. The extent of this research depends on our knowledge of the area and on how old and therefore probably obscure the survey evidence is expected to be. Let's assume our target lot's a worst case and that our research needs to be extensive. There are 4 categories of this research material. There are maps, air photo coverage, field notes of the district lots involved, and survey plans of subdivisions and rights-of-way in the general area. We need a road map to get to the general area. We need a 1 in 50,000 topographic map showing cadastral details in order to get up the appropriate logging road or trail to our target lot. We need recent air photo coverage of the area so that we can see what's on the ground now and compare that to what the original land surveyor said that he found. We need the field notes, not only of our target lot, but of the 8 surrounding lots. We need the 4 lots that touch the sides and the 4 lots that touch the corners of our target lot. Any of these 9 land surveyors may have created the evidence that we find on the ground when we get there. Because we know our survey was done a long time ago and the corners may be difficult to find, we need to expand our research to include any more modern surveys in the general area. We need to search the local land title office and lands records for any subdivision plans in the adjacent lots or any plans of power line, pipeline, highway, or railway surveys in the general area. A modern corner a mile or more away may well be the best place to start our search. Now that we've collected this massive research material, it's necessary to make an index in order to use it efficiently. In this case, we've used a 1 in 20,000 Lands Department reference map for our index. We've numbered the field books, and along each surveyed line, we've written the field book number and the page number pertinent to that line. As you can see, that there'll be 2 pages in each of 4 books that deal with any particular corner. We've plotted the photo centers of the flight line we intend to use for our coverage there and plotted the flight numbers. We've plotted a power line right-of-way along here with its plan number, and we've plotted a subdivision plan in the general area with its plan number. Now let's go over and have a closer look at how we use the air photographs. First thing we need to establish is a rough photo scale. We do this by measuring between 2 identifiable points on the photographs and those 2 same points on our 1 in 50,000 map. Now we know the scale on the 1 in 50,000 map, so we're able to deduce a rough scale for the photographs. Now here we've prepared a transparent overlay of our target lot. We've plotted our target lot on this transparency, and on the lot lines that were surveyed, we've plotted what the surveyor found when he originally did it. We've plotted several creeks, a lake, 2 ridges, another lake, and we're prepared then to slide this overlay over our photographs, line it up with those identifiable features so we have an exact fit, and find out exactly how our lot appears on the ground. Now we slide this around until we have a fit for all the detail.
All the creeks fitting and the lakes fitting fairly well, and the two ridges. And we now have a bird's eye view of what we're likely to find when we get out there in the field.
We've collected our research material and studied it. Now we're ready to go out in the field and find one of those corners. As a survey crew, we take along many kinds of equipment: transits, electronic distance measuring equipment, tripods, and survey posts. Over here to one side, we have the necessary equipment list for searching for old corners. For direction, we need a compass. This is a prismatic compass. Its main advantage is that you can read the bearing as you're sighting down the line. For distance, we either use a steel tape and clino, or with the clino we use a belt tape. This belt tape contains 2,000 feet of biodegradable string, which we stretch through the bush, and a counter that measures it off for us. This is our handy-dandy pin finder. It finds iron shanked posts. Of course, it won't find our aluminum pins or any old wooden posts, but it's invaluable for finding the iron ones. We take along a shovel, of course. It's for uncovering the tops of those iron shanked posts that we just found with our pin finder. We, of course, don't use this to dig around for any old wooden posts. The only person that should be digging around for those is the land surveyor himself, who's actually going to replace the corner. An axe is basic survival gear. We always carry that in the bush. You can cut yourself firewood or a crutch, possibly a survival whistle out of a willow branch if that becomes necessary, but don't use it to open bearing trees. Even land surveyors shouldn't open the bearing trees unless they absolutely need to use the distance to replace the corner. We have to take along our air photos, plans, and field notes, of course. We have a pocket stereo for the air photographs and a calculator with trig functions to reduce our slopes. We're going to need to have some orange tape to mark whatever we find in the bush. We should wear a red vest so that people can see us through the twigs and leaves. And of course, don't forget your lunch. Now let's go out and take a look at how we use some of this equipment out in the field. First, our primary direction finding tool, the magnetic compass. We all know that magnetic compasses point toward the magnetic North Pole and toward trucks, railroad tracks, guardrails, fences, and all that other iron stuff. We need to check to see if we're carrying any of these adverse influences with us before we go and run a line through the bush with our compass. Luckily enough, my eyeglasses don't seem to affect it any. My wristwatch moves at 4 or 5 degrees at close range, so it better go in my pocket. My pocket knife, however, is very magnetic, and I probably better leave that in the truck. The axe at close range has some effect, not as much as you might expect, but we have to be very careful of our steel tape. It's so magnetized that we'd probably better stand well back from it before we read anything with our compass. One of the things you need to establish in order to use your magnetic compass is the local magnetic variation. You can get this magnetic variation off your 1 in 50,000 map from an isogonic chart of the province, or by comparing your magnetic bearing to the bearings shown on a local highway right-of-way plan, or any other right-of-way for that matter. In this case, the crew on this highway plan have found 2 indivisible monuments on a tangent. Because we know that iron shank pins cause local attraction, and for better indivisibility, we are offsetting to the shoulder of the road. Reciprocal bearings taken between these targets should be 180 degrees apart. If they're not, expect local attraction and find a new check tangent.
If they are, then this magnetic bearing compared to the astronomically derived highway bearing gives you your local magnetic variation. In addition to direction, we need to be able to measure distances. The first distance measuring device we'll use is our truck's odometer. It should be checked against measured kilometers whenever possible to verify its accuracy. The odometer can easily be read to 1/2 tenth or 50 meters, and with practice, more refinement in the reading can be achieved.
By using the odometer, we've arrived at a spot where our research tells us the old lot line should cross this road. The timber looks old enough and undisturbed, so we're going to go in to the trees and see if we can find evidence of the old cut line and the quarter blazes on that line. Okay, let's spread out and see what we can find. This is the blazed line we were looking for. The line was cut out, and the trees within 6 feet of line were cut with 2 blazes 90 degrees apart on the side of the tree facing the line. This is a good example of what a quarter blazed tree looks like 40 years after it was cut. And we're going to go down the line and put orange tape on all the blazed trees and cut stumps, and using our compass, search in the direction of the target corner for more evidence. We've come up this quarter blazed line and found a logging road, which the old notes indicates crosses the lot line 4 chains from the corner. It's time to start measuring up to the corner to find exactly where the old corner is. Steel tape needs no introduction to anybody, and it's more accurate than the compass in a compass and chain traverse, as long as a few precautions are taken. We have to pull it tight and keep it straight and measure the vertical angle with a clino in order to have an accurate survey. The clinometer consists of a sighting tube, a level bubble. In the sighting tube is a crosshair, and half of the sighting tube has a 45-degree mirror on it, which looks vertically up at the level bubble when it's in adjustment. We read the vertical angle off this scale on this side using this vernier when it's all set correctly to read the vertical angle. Clino can be used for other purposes. If you need to find tree heights in order to figure volumes, walk along a contour through the base of the tree until the clinometer reads 45 degrees to the top of the tree. Pace over to the base of the tree, add your eyeball height, and you've got the height of the tree. With a compass and steel tape type of traverse, it takes 2 men to run it. There's a way to do this kind of traverse by yourself using this belt tape and a clino and a compass. You tie off this 2,000-foot roll of biodegradable string to a bush. You read and book the vertical angle with the clino. This is a belt tape. It contains a 2,000-meter roll of biodegradable string, which runs out over this drum here and is counted off by a counter in decimeters. It has a button for zeroing the counter whenever you require that. And with your axe and lunch, you should be able to run this kind of traverse by yourself. Here we are at the measured distance from the old logging road where we should find our lot corner, and we have. Usually the first thing we find are these old bearing trees. In this case we found 2 of them.
Here you can still see the axe marks in the bark and the church window-like shape of the original blaze, rounded at the top and squared off at the bottom. These BTs shouldn't be chopped open by anyone but a BC land surveyor, and then only if he needs to use them to establish the true corner. In this case, we were lucky and found the corner as well, an old post and a stone mound. This 4-foot-high wooden post in a stone mound with 3 or more bearing trees referencing it was a typical district lot corner in the wooded part of our province prior to 1947. Having measured further down the line to a point where our subdivision plan says we should have found an iron pin, we weren't able to find the iron pin, but we discovered this bearing tree carved on an old rotten stump. As you can see, it says BT 50.6. We're going to measure back from this to roughly where the pin ought to be and see if we can find it with our pin finder. A piece of equipment that's invaluable for finding any of our survey posts with an iron component is this magnetic locator. It operates by having 2 coils, one at the bottom and one 2/3 of the way up, that detect the difference in magnetic flux. It finds all sorts of things. It screams very nicely past an axe head. And you'll find all sorts of things in the bush with this. In fact, you'll spend a lot of your time finding old tin cans. But over here we have the remains of what looks like a pile of stones, and I expect that we're going to find our iron pin in here. It shouldn't be difficult to detect. I'd say we have it all right. Yeah, there we are. This iron pin isn't the correct kind of monument to be found at a district lot corner, so we're going to replace it with a Type 4 pipe post. We've replaced the iron pin with a brass cap Type 4 monument, built the available stones into a stone mound for reference, and put a reference wooden post in, carved mon here. We've carved a bearing tree over there, and Ted and Tom are going to measure to the face of the blaze. The measurement is from 1 meter above the post to the face of the blaze.
9.65.
Okay, carve it on, Tom. This is what a newly cut bearing tree looks like. Here Tom is just carving the distance into the face of the blaze. Continuing on from our post, we've cut out a new lot line. This gives you an idea of what a newly cut and quarter blaze lot line looks like. With Tom and Ted in there cutting the quarter blazes. The standard marking for a district lot corner in British Columbia was a 4-inch square, 4-foot-high wooden post, referenced in several different ways, until 1947. In 1947, we changed ours to a pipe post. However, Dominion land surveyors were putting iron in the ground from 1881 onward. Their first post was this 36-inch high iron rod squared on the top and pointed on the bottom. And a few years later, they changed to a 30-inch solid iron rod squared at the top, slightly smaller in diameter. And in 1915, they put out a concrete-filled iron pipe with a brass cap on the top. However, they still called it an IP. So from 1915 on, something looking like a pipe post was in the ground in some parts of the Peace River block and the railway belt. In 1947, when British Columbia decided that we should have something equivalent to that, we modeled this copper tube brass cap pipe post on a Dominion iron pin, but we call it a PP. Because it's difficult to set these things, it required a 30-inch deep hole to be dug. The post evolved over the years. One of the first models was this brass spear, which went in first, and a pipe post down over the top of it. It was easy to break and rather difficult to set in hard ground. The next thing was this aluminum cap on a capped iron pin. It was easy to set, but the aluminum cap corroded very easily. Our most modern version is this brass cap that fits over a piece of rebar. The rebar is peened to hold the brass cap on. It's fairly easy to set, and it doesn't seem to have any corrosion problems, so it's the one we're going with right now. The most common corner you'll find is this standard iron pin marked BCLS near the top. It's not correctly used to mark a district lot corner, but it's what you'll find at all subdivision corners in the province. Very few wooden posts are used for anything anymore. Usually the first thing you discover at one of these modern district lot corners is one of these two styles of reference post. One of these 3-foot high, read 1 meter triangular wooden posts marked MON on the side facing the pipe post, or a 3-foot high, again read 1 meter, galvanized angle iron with this plate bolted at the top on the side facing the pipe post. The 1-foot high white painted triangular reference post common to city subdivisions is set beside our standard iron pins. This reference post is marked IP on the side facing the iron pin and has the appropriate subdivision lot numbers on its other two faces. Where no BTs were available in BC land surveys and in Dominion surveys of the Peace River Block and Railway Belt, pits and mounds were built to reference corner posts. Here's an example of pits and mounds at a wooden post. The closer edge of the pits are 5.5 feet from the post. The pits are oriented northeast, southeast, southwest, and northwest of the post and are 3 feet square and 18 inches deep. The mound is 5 feet square on the base with the corners oriented in the cardinal directions and 30 inches high. Dominion land surveyors, iron posts came into use in 1881, but they had a lot of trouble making up their mind as to how these pits and mounds should be placed around the post. Their first iron post was 36 inches long, and it went into the middle of the mound, just where the wooden post had been. Next, they moved the pits and mounds south 3.5 feet, so that the iron post was at the north corner of the mound, and the pits are no longer symmetrical around the post. In 1915, their iron post evolved to the brass capped model. They finally decided to put the post back in the center of the 4 pits, and either no mound was built or a mound 10 feet to the south was built. It isn't always possible to set a post at the true corner of a lot. A wooden post set on the line to witness an inaccessible corner is surrounded by a conical stone mound or a ring trench and conical earth mound. After the Dominion land surveyors changed from the wooden post to their iron post in 1881, the regulations as to the position of this trench and mound changed 4 times between then and 1915. At first, the 36-inch iron post went in the center of the mound, just where the wooden post had been. Then, when their iron post changed from 36 to 30 inches long, they put them at the edge of the mound closest to the witnessed corner. Next, for some years, they put the iron post in the trench closest to the witnessed corner. When the new brass-capped iron post came out in 1915, they put it back in the center of the trench and either built no mound or built a mound 10 feet along the line away from the witnessed corner. Just imagine what the mounders of old called the writers of the regulations as they threw or carried the dirt that extra 10 feet. We have looked at how district lot corners are marked and the techniques we use for measuring to corners that are difficult to find. However, we should not overlook the obvious. Local farmers and landowners often know where their corners are or used to be. They or their grandfathers may have built the fence down the old survey line, and the fence might lead you right to the corner. Your rough survey must be sufficient to identify the boundaries of the subject parcel on the ground, whether by survey posts or other evidence such as cut lines and old fences.
It's just down here somewhere by this post, I think. Oh, there it is.
That's just what we needed. Thanks very much. That'll get us started.
You're welcome.
Yeah, looks like this iron pipe is the corner. Here's a reference post stapled to the fence. And this looks as though it's part of the old original wooden post. It's a nice pointed top. Yeah, thank you very much, Mr. Tipton.
You're welcome.
That's just what we needed. As this presentation is only an introduction to the complex subject of finding and interpreting old survey evidence, feel free to direct any questions you might have to the Office of the Surveyor General, Ministry of Lands, Parks and Housing in Victoria, BC. And happy hunting. Thank you very much.
You're welcome. You're welcome.
Your axe, probably your lunch. You should be able to run this kind of traverse by yourself.
A little closer, right?
It's digging right. We always put them 2 feet away until the new post came out and said it was supposed to be 8 centimeters.
It isn't always possible to set a post at the true corner of the lot.
The odometer can easily be read to 1/2 a tenth, or 50 meters. See what I mean?
Blazing saddles. All right, here we go. Action. Okay, rolling and recording.